variation में तो aldehydes. So amines really to aldehydes to form what you know Gibbs base. Okay, aldehydes really to amines to give us Gibbs base. So let's see both aliphatic and aromatic. We take C2H5 NH2 plus. If I take H CH3 C double bond O H. Okay, or I can write like this: O double bond C CH3 C double bond O H. You get a hard one. CH3 CH2 double bond N C2H5. This is called what? Ethylene. Ethylene. This is what? Gibbs base. What? Gibbs base. So aldehydes relative primary amines to form what you know ethylene amines called what you know Gibbs base. Okay. Take benzaldehyde. Okay, aniline, benzaldehyde. Okay, so aromatic amines like anilines will be your aromatic aldehyde to give what Gibbs base. Okay, your benzaldehyde aniline, clear? So aliphatic as well as aromatic amines will be your aldehydes to give what this Gibbs base. This is also called what? This is what Gibbs base. Okay. Number 5. Action method. Grignard's reagent. Okay, so already we have discussed reactions of Grignard's with phenol. Okay, so where we are getting an alkane. Here also, okay, the Grignard's reagent will the amines to give an alkane. See, if I take CH3, CH2. NH2, okay, plus C2H5 MgBr. Okay, so what happens? So this ethyl magnesium bromide Grignard's reagent. Okay, here this is acting in what nucleophile. Okay, so we get what here CH3 CH2 NH2 MgBr plus CH3 C. That means this C plus 5 and H will form what? Alkane. So when amines are read with the Grignard's reagent, then an alkane is formed. Clear? Now electrophilic substitution reactions of aniline. Okay. So we discuss how the electrophilic substitution reactions occurs in aromatic amine, that is aniline. We know aniline, the NH2 group present in the benzene ring is an ortho-para-diating group, and this NH2 group is highly reactive. It makes the benzene ring highly reactive towards electrophilic atom. The NH2 group presents make the benzene ring so reactive that we are unable to get a single substituted product like either ortho or para. If you go for halogenation, we get a tri-substituted aniline. For example, if you react the aniline with the bromine water, we get what? 2,4,6 tri-bromo aniline. And similarly, when you go for nitration of aniline, the NH2 group is so reactive that, and also because of the oxidizing nature of nitric acid HNO3, and also due to forms of anilinium ion, we are not going to get the desired ortho and para products. We are getting meta products here. We are getting para near about 51%, meta near about 47%, and 2% of ortho product. So here also the same problem we are facing. We are not able to get the desired ortho product or para products. So if you want to get the ortho or para products as usual, then we have to protect the activity of the NH2 group present in the benzene ring. So to get either ortho or para product, we have to protect the NH2 group. How can we protect them? For this purpose, we have to react this aniline, this NH2 group, with either acetic chloride or acetic anhydride in place of pyridine base. So here the NH2 group will convert to NHCOC3. Once this group will convert to NHCOC3, then the activity of the NH2 group will be reduced. Then after we can go for bromination or we can go for nitration. Here we will get what? Ortho and para substituted product. Then after we can go for acidification to get the desired ortho and para bromine or ortho and para nitro aniline. Okay. So NH2 group is ortho para diating and is highly reactive. Due to highly reactive nature of NH2 group, we are not able to get the single ortho or para substituted product. For this purpose, first of all, we have to protect the NH2 group by treating with your acetic anhydride or acetic chloride. Then we will go for halogenation or nitration. Okay. Then after we go for acidic hydrolysis to get the desired product. Let us see how this is happening. First of all, we go for bromination. So electrophilic substitution reactions. Okay. First one, bromination. So can you see if I take ending, okay, plus bromine water. एक क्वेश्चन लिक्विड वाटर 2 4 6 tribromo ending. Okay. Now if I want to get so only ortho or only para, what I will do? First of all, I will take ending. Okay. Then I will value CH3CO whole 2O acetic anhydride with value building base. So what happened here? NH COCH3 and what value? CH3COH. The value CH3COOCOCH3. So CH3CO minus has passed. We remove his value CH3COH and we get value NHCOC or CH3CONH. Then after, okay, we get value bromine. So we get what? NHCOCH3 Br plus NHCOCH3 Br. Now we go for what? H2O H plus. Okay, so now this NHO becomes what? NH2. Now CH3CO becomes what? CH3COH. So minus CH3COH. And what? Orthobromo and lin. Here's what? H plus H2O. Same here plus CH3COOH. CH3COH. And we get what? Parabromo ending. Okay. So ortho and the parabromo ending, if you want to get individually, then first of all we have to protect the NH2 group. That means we have to reduce the activity of the NH2 group. Then after we can proceed. You can get with your value acetic anhydride C3COCO3. So from that we will get what? N-phenyl estamide. N-phenyl estamide. Okay. Then after this undergo halogenation to give your ortho and parabromo. Then we go for acetic hydrolysis. Clear? Similarly, if I will go for nitration, if I take a nitrating mixture, HNO3 concentrated, H2 support the concentrated, paranitro, metanitro, the orthonitro part is sterically hindered. Okay, so nitration of ending by the use of nitrating mixture is very difficult because of the highly reactive nature of NH2 group, number one, Number two, oxidizing nature of the nitric acid, because nitric acid is a strong oxidizing agent. And again, what the conversion of aniline into aniline ion. So for this purpose, what we are doing, we will protect this NH2 group by taking your acetic anhydride in place of what your pyridine. So if I take what your NH2 CH3 CO whole 2O by pyridine CH3CO liquid water NH COCO3, okay. Then what? HNO3 and H2 photo concentrated, okay. So here I will get what? NHCOCO3 NO2 plus NHCOCO3 NO2, okay. So now this H2O H plus minus C3CO, you get what? NH2 NO2 para nitro aniline. Then here also same thing, H plus will get what? NO2 NH2 ortho nitro aniline, okay. Para nitro aniline and what will ortho nitro aniline. Clear? So direct nitration of aniline is not possible, okay. We have to go in this path. We have to protect the NH2, okay, by converting value CH3CONH, okay, and finally your estamide. Clear? Similarly, if you go for what? So this value is for nitration, okay. So nitration of aniline is not possible alone because of obviously because the highly reactive nature of NH2 and also the your oxidizing nature of nitric acid and also conversion of aniline into aniline ion, okay. So that can be your carried out by protecting the NH2. Clear? Next we go for your sulfonation. For your sulfonation. So how can you go for sulfonation? Sulfonation you can do with your concentrated sulfuric acid, okay. Where we get what word? Para amino benzene sulfonic acid or sulfonilic acid. Let's see sulfonation. Sulfonation, if I take what? Aniline plus H2SO concentrate I will get what? NH3 plus H2SO minus, okay. So from this I will get what? NH2 SO3H. This is called what? Para amino benzene sulfonic acid or called what? Sulfonilic acid. Okay, this is called what? Para amino benzene sulfonic acid or called what? Sulfonilic acid. Here you see one molecule, this is what? Basic group This value acidic group. So one molecule contains both the acidic group and the basic group. So this shows an amperic nature. And here what happens, from this SO3 has what happens here, you see NH3 plus SO3 minus. So from SO3H2, one proton is coming to this place. So this becomes part of Na3 plus. So this becomes part of SO3 minus. And there is an equilibrium. And such a molecule which contains two charges in the same molecule, plus and minus. Such a ion is called what? Dipolar ion or Zuiter ion. This is called what? Zuiter ion. Okay? Dipolar ion. Okay? So, ending ready-to-go constant sulfuric acid to give what? This is your aluminium salt, and this gives what? The para-amino benzene sulfonic acid called sulfonylic acid. Okay? And this is what? This is this real matter to give what? To give the compound. This species containing what? The plus charge and minus charge both. This is called what? A Zuiter ion or a dipolar ion. Okay? So these are about the electrophilic substitution reactions of your ending. Clear? So far we have discussed about the various chemical properties of your aromatic amine as well as aliphatic amines. Now it's time to test the primary, secondary or tertiary amine. Whether a given amine is primary or secondary or tertiary. So that now we want to discuss. First of all, test for primary amine. The most important test for primary amine is what was the carbonyl amine test. The most important test for primary amine is what was carbonyl amine test. But what we are doing? We are taking the amine and we are adding chloroform and KOH. When chloroform and KOH are treated with primary amine, then an isocyanide or carbyl amine will be formed with an unpleasant smell, very bad odor. And this unpleasant smell indicates the presence of primary amine. And this reaction is not given by secondary or tertiary. And this reaction is called what? Carbyl amine reaction. Carbyl amine reactions are given by primary amines where primary amines are treated with chloroform and KOH, where we are getting an isocyanide or carbyl amine having very bad odor or unpleasant smell. Similarly, also we can go for Hoffman's mustard oil test. This is also given by the primary amines. When primary amines are treated with the carbon disulfide, aliphatic or aromatic, carbon disulfide, and the product obtained is heated with HgCl2 in case of aliphatic primary amines. Then we will get the compound with very unpleasant odor of mustard oil. The primary amine will be converted to the isothiocyanate. And this isothiocyanate NCS formula is having a bad odor of mustard oil. It is called Hoffman's mustard oil test. Also given by aromatic. Now to distinguish between primary, secondary and tertiary amine, we can go for Hinds bar test. In the Hinds bar test, what we are doing, we are treating the amine with your benzene sulfonyl chloride called the Hinds box reagent. The Hinds box reagent is a benzene sulfonyl chloride. When treated with your primary amines, we will get the product that when treated with your alkali KOH, the product will be soluble. Whereas if I have the secondary amine when treated with your Hinds box reagent, benzene sulfonyl chloride, and the product obtained is dissolving KOH, then it is insoluble. Whereas the tertiary amines are not reacting with your Hinds box reagent, that is your benzene sulfonyl chloride. So this can be easy to distinguish between your primary, secondary and tertiary. And regarding your only secondary amine, already we have discussed about the Lieberman's-Nitroso test. In the Lieberman's-Nitroso test, what happens? The secondary amines are converted into nitroso amines. The nitroso amines when are having the yellowish oil liquid, that when treated with your crystal phenol warmed, we are getting your greenish color, and that when diluted with water, we are getting a red color, and if you treat with alkali, we are getting a deep blue color. So this is a test for secondary amine. So Lieberman's-Nitroso test is used for the secondary amine, to test secondary amine. Carbonyl amination is used for testing of the primary amines, and also for primary amine we can go for with nitrous acid. When primary amines are reacted with nitrous acid, already we have discussed on nitrous acid, then your primary alcohol is obtained with the effervescence of nitrogen gas. It's not given by other amines. Okay, so primary amines can be tested by your nitrous acid reactions. Also can tested most brilliantly tested with help of your carbonyl amination. Okay, carbonyl amination where the amine with your chloroformation KOH to give your unpleasant odor of alkyl isocyanide. Okay, secondary amine we can go for Lieberman's-Nitroso test, and primary amines also can go for your Hofmann's mustard oil reaction. Okay. And to distinguish between your primary, secondary, all the three, we can go for what your Hinds box test. Okay, that your Hinds box reagent benzene sulfonyl chloride. Okay, let us see one by one. First of all, we go for what your test for amines. Okay, number one. Carbonyl amine test. Number one, what your carbonyl amine test, or you can say what your carbonyl amine reaction. Carbonyl amine reaction. What will do here? We take your CH3, CH2, NH2 plus CH3 plus KOH. Alcoholic, here what your CH3, CH2, and C plus H2O plus KCl. Okay, 3 KCl, 3 KOH. Okay, three H2O. Okay, now see CH3CH2 NH2 ethyl amine CH3CH2. Now guess what is CH3CH2 and NCO3 CO2 NO and CO3 CO2 and C. Okay, now water and acid. This isocyanide form is called what? Ethyl isocyanide or called what? Ethyl carbonyl amine. And this is what? Unpleasant odor, bad smell. Okay, so from this we can determine what the presence of primary amine. Okay, similarly I can also go for what aromatic primary amine. NH2 plus same thing CH3 plus KOH. Okay, we get what? Phenyl isocyanide plus 3KCl plus what? 3S2. What? Phenyl isocyanide. Unpleasant odor. What is unpleasant odor? Okay, so this is unpleasant odor of isocyanates indicates what? Presence of primary amine. And this reaction is not given by secondary amine or tertiary amines. Clear? Let us see the Hoffman's mustard oil test. See, what happens here? C2H5 NH2 plus C double S carbon disulfide primary amine. Okay, carbon disulfide. What happens here? Okay, so we get what? C2H5 NHH C single bond S minus double S plus. Okay, now this carbon becomes positive. So when this trigon breaks here from sulfur, we go to sulfur. This trigon carbon becomes plus electron deficient. Now the efficient nitrogen can attack here. Okay, so we get what? This one, and the positive of carbon will come to your nitrogen. Clear? Now here what happen? C2H5. Again this becomes unstable, so this comes to space. Okay, this comes to space. So we get what? C2H5 and no H0 C SH. Okay, now then after and this is equal to heat. Okay, here also this complete pressure. Okay, and this C2H5 and downward C downward pressure also H2. This is what you know, ethyl isothiocyanate. Okay, ethyl isothiocyanate. Okay, mustard oil or okay, unpleasant. From this say unpleasant odor of mustard oil indicates the presence of water, the primary amine. Okay, hence about test now. Okay, so what will be here? CA3 CH2 NH2 plus benzene sulfonyl chloride, benzene sulfonyl chloride divided benzene sulfonyl chloride called what your Hinz-Bosch reagent. Again, what your CH3 CH2 NHO SO okay, and this when you have to KOHO solid. Okay, so primary amine is what ethyl amine, primary benzene sulfonyl chlorides. Okay, to give this product which on treatment with alkali becomes what soluble. But if I take CH3 CH2 HO, same thing, Cl so what happens? You get what C2H5 NC2H5 H double O. Okay, KOH insoluble. Okay, so why this happens? Here you see, when I am taking primary amine, so I am C2 NH2, and when it treated with the Hinz-Bosch reagent, we are having a NH here. This is the acidic hydrogen, and this react with what the alkali, so becomes soluble. But here already this has reacting here, and in this compound we are not having the acidic hydrogen. So when I am treating this one with KOH, it becomes what insoluble. Okay, and if I take tertiary also, then it is not reacting with the Hinz-Bosch reagent. So this we can use to distinguish between your primary, secondary, and tertiary. Right? Primary amine Hinz-Bosch reagent, then KOH soluble. Secondary amine Hinz-Bosch reagent, then alkali not soluble. Tertiary amine not reacting with the Hinz-Bosch reagent. Okay. Thank you. So next we will discuss what is the basic nature of amines.